आफ्टरनून एवरीवन. चलो बेटा आ जाओ, जल्दी आ जाओ. गुड आफ्टरनून. क्वेश्चन नंबर 25. व्हाट शुड बी द आंसर? आई ट्राइड नंबर ऑफ टाइम्स. ओके, लेट मी चेक. Yes. Question number 25. The option is given in the key is wrong. Actually, the answer is minus 3x square minus 5. It's not D. It's B. Question number 25. There is a mistake in key. There is a typo error in the key. Typo error in the key. That is, answer is B. Question number 25. 25 question, answer is B. Typo error. Answer is B. Those who are having any trouble with 25, so please make a correct in it. गुड आफ्टरनून बेटा, गुड आफ्टरनून. जल्दी 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 आ जाओ, आ जाओ. क्लास शुरू हो रहे हैं 1 o'clock. Okay, so I do one thing. T28 is a wrong question. T28 is wrong question. T28 is a wrong one. The question options are completely mistyped, so therefore you won't get any answer from the options. So this is the wrong one. Leave it. Question number T28, please leave it. Naivedya, what happened, ma? I have already given that, right? bit.ly/2021 key. 2021 key. Workbook solution link. bit.ly/2021 WBSOLN. WBSOLN. bit.ly/2021 WBSOLN. T12. So it is the mechanical 2014. Please refer the theory book. Please refer the theory book T12. Vaishnavi. Please refer the solution in theory book. See, if it is the previous gate examination question, why don't you refer the solution in theory book? Okay. Yes, the class is just started. Already 5 minutes. So let's start. I have not started anything. Just I have given the links. I was reading your chat. I was giving the links. Okay, that's it. Just I started, my dear. I have not yet started. I'm sorry. See, you people will come late. So then you are asking me, chatting with me, and then all these things. It will take a lot of time, my dear. If possible, tell first chapter T23 question also. Okay, I will go on doing this one only, beta. I will not start the next concept. See. Okay. Harsha and everyone, all of you, please listen. For try yourself question solutions, I'm putting the heading. Don't ask me again. This already I told you, but you are asking me again. See, I'm putting the heading and I'm writing. Okay, please make a note in your notes. For try yourself solutions, go to madeeasy.in, madeeasy.in, then go to quick links, and then go to PYS, practice yourself solutions. Okay, PYS. Then go to civil engineering. Then go to engineering maths. Then a PDF will be downloaded. A PDF will be downloaded. So this is the path. I've written everything. Please don't ask me this again. 36th question in chapter 2. Yesterday I told you, Harsha. In the class I told you, someone was asking that question. I have replied the solution for the 32, 36. Just I repeated about 3 to 4 times of my statement. I think you forgot. Class 10 to 1. Sir, how much you have taught today? So I hope everybody got it. शुरू करते हैं class. All of you, shall we start a class? Because class is important, my dear. Okay, class is important. We need to do so a lot. Yes, for CS students, we have to do the same. Why not? Why not, beta? We are doing the same workbook for everyone. Then PDF will have 40 pages. Maybe. Hello, sir. I joined today's class now. How much have missed the topic? Half of the topic is missed. The calculus we have started and we have completed 50%. Okay. So remaining 50%. Acha. I'm going to do integral calculus. Differential calculus is finished. We are going to move on to integral part. That is integral calculations. Calculus. Next. Save it into notes folder. Yes, Munibali. Correct. Let's start, sir. Okay, Sekran. I need to follow you. Otherwise, you will never waste the time. I have seen you. Very good. Very good. That always to be there in the class so that the class will be so productive and there will not be any time waste. So what is TYS? Oh my God. TYS means try yourself solutions. Try yourself questions are there in after the every chapter. Okay. So the solutions of those questions, if you want, you can go to this path, Mr. Subhi Goel. चलो बेटा आगे. और सुबी गोयल का बहुत कहाँ सुनते हो, समझ में नहीं आता है. थोड़ा अलर्ट रहना जी. Yes, beta. Okay, no issue. Nothing, beta. It's our time. 10 minutes means we would have completed one question. Frankly speaking, no problem. I don't have any problem. It's your time. Okay, I don't have any problem. It's your time, beta. That's why I'm thinking of it. Chalo, chalo. Okay, let's start the class, sir. Okay, right. Shruti, let's start. Okay, चलो बेटा चलो हम शुरू करते हैं कोई क्वेश्चन को. I think everybody have changed this. 25th question का answer is answer B, not key is wrong. Okay, so this one is correct. Sometimes typing error will be there, so in a hurry we may not do the proofreading. So that is why 1-2 questions will have some problem. So I wanted to change them. Let's see. Okay, I'm just making a note. So please take it down. चलो बेटा ये क्वेश्चन देखते हैं. See, actually, I used to tell the students every time that there are certain functions where the question can comes on that. So then immediately you should understand that okay, let us study this type of functions. So you should you should keep an eye on those functions, because so this is one function which I used to take in the questions. So this was asked in 2022 civil engineering examination here. Chalo beta wo kya hai? The function is nothing but maximum of this 3 minus x and x minus 1. The maximum of 3 minus x and x minus 1. Let us draw the graph. So one function is that. So the function f of x is the maximum of, okay, 3 minus x and x minus 1. So this one is nothing but y plus x is equal to 3. Correct? And this one is nothing but y, y plus x. एक minute. So this I will write if y is equal to, if I take this is y is equal to, if I take, so this equation will be x plus y is equal to 3. And this equation will be here. With this one go this side and this y comes this side. So x minus y is equal to 1. Right? So let us draw these graphs. Let us draw this one. Okay? Now, and this is 3 and this is 3 suppose. Now this is the, see, because this line is nothing but this. So this is the first equation suppose. And this is the second equation suppose. Now I have taken the first equation. Now I'll take the second equation with a green color one, right? So this one is a second equation. So draw this x minus y is equal to 1. X minus y is equal to 1 means it can be understood as x by 1 plus y by minus 1 is equal to 1. So y is minus 1 here is this, okay? Then x is 1 is this, right? So then go this way. Now this is the point of intersection. This is the point of intersection. And this is 1. This is 1, right? This is 1 at x equal to 1. At x is equal to 1. So what is this point of intersection? Let us solve this. Solving 1 and 2. Solving 1 and 2, what do you get? 2 comma 1? Absolutely. 2 comma 1. So x is equal to 2, y is equal to 1. So that means I'm going to show you this one with another color. So this point of intersection is 2, right? And this is 1, right? Okay? Okay, my dear students. So what is the maximum of these two functions? So now let me write that. So now these are the two functions. Now I am going to write the f of x is equal to the maximum of x, sorry, x minus 1 comma 3 minus x here, right? If you draw this, so what will be the shape of it? Anybody? What will be the shape of it? If it is origin, okay, this is 2. I'm saying that this is 2, okay? Okay, now what is the maximum of these two curves? The maximum of these two is nothing but C. Maximum means above. So from here to here, this is the maximum one, right? But from 1 to from 2 to, right? From 2 to infinity. From 2 to infinity, the maximum is this, because the curve whichever is upper side, that is the maximum value. So if you see from minus infinity to 2, the maximum among these two is this curve. This value is maximum, these y values are maximum, right? Okay, next from 2 to infinity, this value, this maximum value is, these values are maximum here. So therefore the graph will be taken as here, as it is 3 here. Now this one, this is 2 here, this is 2. So this is the graph you are seeing, that this is the f of x, this is the f of x you are saying about. Now tell me, my dear students, let us, after right understanding these graphs, let us look at that each option. Let us look at the each options here. It is continuous on its domain. Yes, is it continuous on its domain or not? It is continuous on its domain. See, the question is that is or true. Is or means what? Is or means what? Is or means here multiple selective question. So this is MSQ, multiple selective question here. Okay, this is MSQ here. This is MSQ here, MSQ. So it is continuous on its domain. Yes, option A is true. Then it has a local minimum at x equal to 2. Yes, at x equal to 2, it is having local minimum because it is a corner point. It is a corner point. So this is one example. This is one example here. You can see that at the corner points, the function can have a local minima or local maxima. I told you in the differentiation concept. So this is what we can see in this graph here. So I can say this statement is also true, that it has a local minimum at x equal to 2. Next statement is it has a local maximum at x equal to 2 is wrong, because it is minimum. Now it is differentiable on its domain. No, because it is having the sharp edge at x equal to 2. Since at x equal to 2 it is having the sharp edge, so it is not differentiable at x equal to 2. So therefore in its domain it is not differentiable always at every point. So therefore it is not differentiable at every point. So therefore I cannot say that this is differentiable in its domain. So this is wrong, this is wrong. So answer is A comma B here. Yeah, Ritan. Thank you. This is the first slide, Harshit Sharma. This is the first slide. Karthik Gupta, see beta in its domain. So domain is from minus infinite to infinite. But at x equal to 2, it is not differentiable. Na? So therefore, it is not differentiable at x equal to 2. So therefore, it is not differentiable in its domain. Okay. So when do you say that it is differentiable in its domain? It is a smooth curve. But it is not a smooth curve. So therefore, it is not differentiable in its domain. It is not differentiable in its domain means it is not always differentiable in the entire domain. It is not. It is differentiable. You see, what is the meaning of it? It is differentiable on its domain means it is differentiable at every x in the. That's what he is saying. That is the meaning of it. But it is not differentiable at every x. So therefore, this statement is wrong at x equal to 2. So therefore, we are removing this case. Priya Mukherjee asking, why not maximum? Oh my God. You can see the graph now. Priya Mukherjee, you can see the graph now. Graph has a minimum na. Maximum kahan hai? Where is the maximum? Maximum means you should get this way. Ashmit Kaur is asking, sir, please explain how it is continuous. See, the graph is continuous. My God. For that differentiable reason is the sharp edge. Right. Yes, Manoj, you are right. Yes, beta. Karthik, I think you have you had a problem with the language. That's why you are asking the doubt. Okay, I understood your concern. But Priya, it is very clear, na? See that? It is having minimum. How can you say that maximum? Maximum is this one, na? I think you forgot the yesterday's entire concept. Ashmit Kaur is also asking that how it is continuous. Curve to continuous hai na? Is the curve is continuous or not? That's it. As simple as that. I think you have not studied the +1 +2 properly. Okay, beta. No issue. No issue. It's not that important now. Now, while I'm explaining only, please understand the things. Okay. Anyway, so I hope everybody understood this. So I will be going into the next topic. Okay, I'll be going to the next topic. See here, there is a question called, okay, I will tell you this one also later. Find the absolute maximum and minimum values of this function. I'll tell you this later. Global minimum. Yes, this question. All of you. You can see that the global minimum of this function f of x is equal to, it is x cube e power minus mod x. It's a printing mistake, beta. It's a printing mistake. It is x cube. It is x cube. It must be x cube. Okay, x cube. It's not. Yeah, 25th answer is B already. Sahil Yadav, I told you. It is wrongly mentioned. Sir, what is that 25B? Question number 25, the answer is B. That's it. Harsha, if it is minimum, we need to take the lower curve. No, sir. Oh my God. Somla, we have taken maximum of these two functions where you are getting the function, okay, where you are getting the new function which has a local minimum but not local maximum. That's what the thing. Why are you mixing both? I don't understand. He is asking the local minimum of f of x. He's not talking about the maximum of those two functions or minimum of those two functions. No, no. F of x itself is the maximum of those two functions. So maximum of those two functions you will be getting as like this. Now we have to find out where it is local minimum. So at this point, the local minimum is there. This is what I am trying to say. Function definition is different. Function in where it is maximum, it is different. Local maximum, local minimum of the function is different. And the function definition where it is maximum is different. Both are different. Please don't mix up both. Yes, it is there. Because it is a previous gate question. Na? It's a previous gate question means it will be there in the theory book also. Okay, okay, beta, okay, right. Okay, Arsha, right. Now this is the question. So we need to find out here the global minimum of this function. The global minimum of this function in the interval minus infinite to infinite. Okay. So it is not a closed interval, right? It's not a closed interval. So let us have the this thing here. Let us understand this function, what it is. What it is. Okay. Now, dear students, when mod x is when modulus is there in the function, we need to redefine the function. So for x less than 0 and for x greater than or equal to 0. For x less than 0, this is x cube into e to the power of minus x. Okay. So then it is x cube into e to the power of minus x. Now, this is what the function is that. Okay. This is what the function. So it is minus x. But we all know that for x greater than or equal to 0, x cube, this function by shortcut number 4, I can say that it has the maximum at x is equal to 3. At x is equal to 3. At x is equal to 3, it has a maximum, right? So this is what the case here. This is what the case. It is maximum at x equal to 3 by shortcut number 4. But he is asking what? Minimum. It is not, he is not asking the maximum. So for this function, it has a maximum at this x equal to 3. So that means you need to discuss only this function here. You need to discuss only this function. So now we take, now f of x is equal to here x cube e to the power of x. X cube e to the power of x for x less than 0. For x less than 0. That is the stationary point. The stationary point. F dash of x is equal to here. If you do this one, it's a UV rule, correct? UV rule. So in UV rule here it is x cube into e power x plus e power x into 3x square is equal to 0. So from this, if you take x square e power x common, then you are going to get x plus 3 is equal to 0. And you know that here you will be getting x is equal to 0. This is not equal to 0, correct? This e power x cannot be 0 at all. So x square can be x is equal to 0, or you can take x is equal to minus 3. So these are the two stationary points you have got. Now let's find out f double dash of x beta. So let f double dash means x cube e power x is already we have differentiated this much, right? So the differentiation of this one is the total one because the same function, right or not? Now the differentiation of this here, this is x square. Chalo, we'll write this differentiation as the whole thing, that is f dash of x. This is f dash of x. The differentiation of this, please listen beta. Again you will ask me, so how you are able to write this one? Please listen carefully. I have to differentiate this f dash of x, that will give you f double dash of x. Okay. Now the differentiation of x cube e power x, that means it is the differentiation of f of x, which is f dash of x. Clearly you understand this, right? Now plus, now the differentiation of this, that is 3 times of x square e power x. I'm telling you, e power x into 2x, okay, plus e power x into x square. This is the differentiation of this. And now if you put x equal to 0, so this, what is f double dash of 0? So it is f dash of 0, right? F dash of 0 plus 3 times of, this is 0 plus 0, right? So then this will go, f dash of 0 is what? F dash of 0 is already 0. So this is equal to 0. So therefore this is 0, right? So at 0 we are unable to get anything here. So we have to go for f triple dash and all, right? So let's go for f triple dash of 0. F triple dash of 0. So f triple dash means it is f double dash of 0, which is 0. So 3 times of the differentiation of this. So the differentiation of 3 times of e power x square is this. So this one is already 0, right? So e power x into 2x plus e power x into x square. Okay, the differentiation of this one is this, right? Then what is the differentiation of this? What is the differentiation of this here? So that is uv here again. So uv means here 2 times of yes, 2 times of here e power x plus e power x plus x into e power x, x into e power x, right? So you are getting at 0. So f triple dash of 0 means this becomes 0, this becomes 0, right? And this becomes 1, this becomes 1, and this becomes 0. So this is goes to be 2 into 3. So but this is equal to also 0 here. So this is equal to 6, which is not equal to 0. Look at this carefully here. F double dash of 0 is 0 and f triple dash of 0 is not equal to 0. So therefore x equal to 0 is a saddle point. X equal to 0 is a saddle point. Hope you got it. Now we'll go for x equal to minus 3. Now what is f double dash of minus 3 dear? F double dash of minus 3. So this is our f double dash of x. F double dash of minus 3, x equal to minus 3. So f dash of minus 3 is, yes, let me put that, f dash of minus 3, right? Then plus 3 times of minus 6 e power minus 3, then plus here minus 3, na? Minus 3 square, it is 9 e power minus 3 here, 9 e power minus 3. So this is equal to 0 here. And this one is going to be 3 e power minus 3. So that is 3 into 3. So it is 9. So 9 into e power minus 3. E power minus 3 is always positive. So therefore it is positive here. Okay. So since f double dash of f dash of minus 3 is 0 and f double dash of minus 3 is greater than 0. So therefore f of x has the minimum at x is equal to minus 3. Now my dear students, at all these points, 0 is a saddle point you got, at 3 it is maximum, at minus 3 it is minimum. So what is the global minimum here? The global minimum will be at minus 3. Okay, so that is what he's asking here. See, the global minimum of this function at x is equal to what? So it is at minus 3 is the answer. Minus 3 is the answer. Okay. Yes, we can remove also. Yes, someone is saying beta. Yes, beta. Yes, very good. So the person is saying that here for x less than 0, for x less than 0, here x not equal to 0 na. So when x not equal to 0, so here we don't need to calculate the, there is no need of discussion of f dash of x at x equal to 0 or f double dash of x. So this is not needed here. Okay. So this part is not needed here. Okay. I hope you understand. So this part is not needed here. This part is not needed here. This part is not needed. This is not needed because x less than 0. Okay, good. X should not be taken as 0 because x is this function we are discussing for x less than 0. Yes, beta, I forgot that point. Sir, why only we have taken x less than 0? For x greater than 0 can also has minima. Dhruv Chatter, we have already discussed. No, beta. For x greater than 0, okay, no issue. If you don't know, you can write it. For x greater than 0, that function x cube e power minus x will be it has only maximum at x is equal to 3 and saddle point at x equal to 0. So no minima at that point. Yes. No, no Dhruv Chatter. Because you have seen here. You have seen here. So even if you do with plus minus, so it is just a matter of plus minus here. So it will be x minus 3, you get it. If you go, acha, Dhruv Chatter, suppose if you want to go for this function, suppose, so the differentiation of this function, the difference will be x minus 3 and this is e power minus x. So here you will get x equal to 3 and x equal to 0. So 0 you got it as saddle point. At x equal to 3 you will get it as maximum value. That's it. So there are no other stationary points here. So the stationary points here you are getting. So here the stationary points are x is equal to 0 comma 3 and here the stationary point is x is equal to minus 3. So these are the only 3 stationary points you have. So therefore, so the global minimum among these 3 points only we have to discuss. Arnav, differentiation beta, please. What you are thinking it is wrong answer. See, this is nothing. You're not listen properly. I told you the differentiation of this one is f dash of x because this is f of x. Simple. So the differentiation of this is going to be f dash of x and the differentiation of this is going to be uv rule. So uv, it is u into v. So we have done the uv rule and you got these points. Proof. Okay, beta. Okay. That is, sir, when range is given minus infinity to infinity, the global maxima, minima, then there is same as a local maxima, minima, because we can't consider the minus infinity as in a closed interval. Yes, Dhruv Chatter, you are right. Anyway, so I'll move on to the next one here. See, I have done the things very complete detail explanation. I have done it. I took all the stationary points. At one stationary point, you are getting the maxima, that is 3. At 0, it is a saddle point, that I have proved it. At minus 3, it is. At minus 3, it is we are getting minimum. Everything I have done with the differentiation and everything, and that too, the differentiation I have done very effectively. I have done. So, if you want to understand the differentiation, it takes some time for you. Okay, watch the recorded session once again, so you will understand that what I told you at the time of differentiation. That is why I say that please listen carefully when I do that. I mentioned it when I was doing the differentiation also. If you don't do that, so it will take a lot of time and some confusion and complexity you will be getting it because of lot of terms. You will not arrive the right answer. So you must be very effective in putting the steps. Okay, chalo. Sir, in stationary point, second line how? Second line how? Second line how? In stationary point, second line how? My God. Here x square is taken common beta, e power x is taken common beta. तो यहाँ पर x बचेगा और यहाँ पर 3 बचेगा. तो x plus 3 into is equal to 0. Just taking the things common. Or now, I think you need to watch the session once again. I request you to watch the session once again because I think you need to deal with the basics. I have given the basic maths link, na? So please go to the basic maths link and otherwise, see, if anybody have any difficulty in differentiation and all, so what you do is go to NCRT book. You need not to do much. You don't do any research or you need not to crack the IIT JEE examination for understanding these basics. Just to go to NCRT, books and just look at the differentiation part and just keep on doing the differentiation. You will understand exactly what we are doing here. And even I will tell you, even if you don't know also, if you keep your mind open instead of putting a lot of doubts into your mind, keep your mind open and you give that energy and that time for understanding the things what I am explaining here, the steps what I am explaining here, also it is enough. You need not to even practice the NCRT because I'm explaining very detailedly that how the differentiation is happening here. Okay. Chalo beta. Right. Sir, question number. I don't. Which question? Okay. Next, I will go for it. Yes. I think yesterday I was doing this, right? ये क्या हुआ? Okay, fine. Come back to the last class yesterday. You see this. I have given a link. And I asked everybody to take the printout of this link notes and come to the probability class. So when I start the probability class, so please come with these notes so that no dictation will be given and no definitions are going to be dictated. No concepts is going to be dictated. Everything will be written in these notes so you can have the proper notes with you. Okay. Chalo. So I told you, I think this, if anybody have missed the this point, so yes, Ankita Mishra. Yes, beta. Yes, that is enough. RD Sharma is enough, but don't do much. Don't do 40-50 problems. It's hardly 20-30 differentiations are enough. I'm telling you, for doing the engineering mathematics, you need not to do that much. You must know the basic how you do it. That's it. Frankly telling, remaining, I will take care. Okay. Right. So because first you are focused to be on basic of differentiations. That's it. Okay. So I think you have taken, everybody have taken these notes. All of you. Everyone. ఇది ఎప్పుడు వచ్చింది? ఓకే. Yes, please do it fast. Do it fast. Sir, I have to solve G main and G advanced problems. No, 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 not at all. Not at all. Not required. No need, Mr. Sandeep Pal. No need at all. If you want, if you have the time, if you have the interest, you do it. No issue. I don't stop you. But for us, it's not required. But for some part of the calculus suits that syllabus. If you want, you can do it, but I don't advise. Oh my god. You are killing a lot of time. Chalo. Extremization. So it is extremization beta. Yeah, extremization of u is equal to f of x comma y with respect to the constraint phi of x comma y is equal to c here. Phi of x comma y is equal to c here. The link is not opening. I can't help you because the link is perfectly opening. Shailaja Tripathi. Go to Mozilla Firefox and download it. Okay, extremization of this function with respect to this constraint here. So, what we are doing is we are maximizing or minimizing a certain function with respect to the conditions. So, suppose if I want to have the maximum profits on my sales, I want to see the daily maximum profits or the maximum profits on my daily sales. So on the first day, I have given 10% of discount. On the second day, 20% of discount. Next day, 30%. Next day, 40, 50, 60. And on seventh day, I have given, buy two, get one free kind of things. Okay. So like that, 70% I have given. Now you tell me. Now, when you tell me that what is the maximum number of sales, if I ask you, if I want to know the maximum number of sales here with respect to the discount, obviously it will be varied because 10% discount will have certain amount, certain sales, and for 20% discount we'll have certain sales, and for 30% another certain sales. Like for at 70% discount, if you when you are providing you'll have a huge sales. So there you will have a maximum sales here. But you everywhere in every discount, on every discount or on every day you are providing one discount, and every day you are counting the maximum sales. But you know, my dear students, the maximum sales was differing. The maximum sales were differing according to the discount you provided. According to the discount you are providing. So therefore here, so there are certain functions so which we have to maximize or minimize with respect to some conditions here. With respect to some conditions. Suppose if I wanted to take one circle, and in this I can take so many rectangles, right? I can take so many rectangles here. If I take this circle and take this rectangle here, I take this rectangle here, you understand? Now, if I talk about the maximum area of the rectangle inside this circle and the maximum area of this rectangle inside this circle will be different or not? How it is different and why it is different? It is different because of on the radius of the circle provided. See, if the radius is higher, then the maximum area of the rectangle also will be higher. Correct or not? So, the maximum value or maximum area of this rectangle will depends on the circle it is provided to us or the condition you provided, that what radius of the circle you are providing it. Okay. So therefore, so I am telling you, so we are doing certain type of questions where we are maximizing or minimizing one function with respect to another function. तो कोई एक फंक्शन लेके आप दूसरी फंक्शन के विथ रेस्पेक्ट टू से हम correspondingly we are taking another function and we are maximizing the given function. ठीक है? Okay, so then this is what the concept we are going to do it. But mathematically how do you do this one? Let's see this. Dear students, my point is that if you want to maximize this, only this without any condition, so x and y are free. X and y can be anywhere on the plane, correct or not? Anywhere on the plane, correct or not? But when I provide the condition, then here with respect to this condition only you have to find out this means. So it is very, very clear the variables in this function will be restricted according to the given condition, correct or not? So that the function is getting restricted with respect to this function, with respect to this function here. Okay, so therefore what I suggest all of you is that what you have to do in this, you have to use, I'll tell you what simple way of doing it. So can you write this y other side? You take y on the other side. So then what happens is that this can be written as y is equal to, yes, if I take y on the other side of the RHS, so then you will have only a function of x. So this is some capital F of x, I take it. Some capital F of x. So this y is equal to capital F of x is representing this constraint, and this constraint you have to take into the function which you are maximizing it. So then the extremize u is equal to f of x comma y. What is y is? That is capital F of x. Extremize this function. So now after using this constraint into this, so this function has become the new function, so which is already with respect to the given constraint, right? So this is to be maximized here or minimized. So now you know the procedure for function of one variable, na? So we can go ahead with this. All of you please take it down, everyone. So now, okay, I think chalo, we'll take some shortcuts here. Achha, before shortcuts, let me do one question, my dear. Just a minute. Let me do one question here. That is question number 48. Please look at the question number 48. 48 beta. So he is asking, Pavan Anugolu, sir, I missed last 3 days classes due to my health problems. So I found the class timings also got changed. So can I continue today, or I need to go through the last classes? Please continue, beta. Pavan Anugolu. So just what you do is another half an hour to 45 minutes. So I'll be discussing this case with the shortcuts only. So I'll not go into the much the concepts and all. Will not use much concepts into this. So maximum shortcuts I will be using here. Okay. So but the concept I have already explanation. This is everybody can understand normally. So what you do is that you continue the class today. Okay. You need not to go to the previous lectures as of now. So please continue because I am going to start the integration part today. Chalo beta. ओके टू मच ऑफ डिस्कशन. चलो 48 क्वेश्चन. 48 क्वेश्चन क्या पूछ रहे हैं बेटा? व्हाट इज दैट क्वेश्चन? इज द डिस्टेंस बिटवीन द ऑरिजिन एंड द पॉइंट nearest to it on the surface z square is equal to 1 plus xy. Nearest to the surface on 1 plus with in front of the constraint. With respect to with respect to beta. Okay, again I read the question. The distance between the origin and the point nearest to it on the surface. So some surface is given. So what is that surface? Is z square is equal to 1 plus xy. Now I take a point on the surface. Let p of x comma y be any point on the surface. On the surface phi. Let p of x comma y be any point on the surface phi. Okay, so let p of x comma y be any point on the surface phi here. Okay, now, and he's saying that the distance between the any point on the surface and the origin is to be nearest. So nearest point. So this point must be nearest to the origin. So please understand, the point on the surface to be nearest to the origin means, can I say the distance between the origin to and this point to be minimum or not? This point you have to understand very clearly, because the logic is taken here. Now here, now let this point of p of x comma y be any point on this surface, okay, which is nearest to the origin. Okay, now I will say that phi here. Okay, right. So therefore here the distance between the origin and the point p of x comma y comma z, the distance between the origin and the point p of x comma y comma z, between these two points, okay, is to be minimum. Shortest distance means minimum distance. Shortest distance means minimum distance. So therefore the d is equal to under root of, yes, what is the distance? Is that x minus 0 whole square plus y2 minus y1. So y minus 0 whole square plus z2 minus z1, that is z minus 0 whole square, to be minimum. Okay beta. So now here this is to be minimum. My dear students, it is the function under root. I want to say one concept here. It is root x is minimum when x is minimum. You know that. It is a in general concept, right? It is a in general concept here. Root x is minimum when x is minimum. So therefore, if you want to make this under root function is to be minimum, first, so this x square plus y square plus z square is to be minimum. So therefore, here let u, here the u is equal to d square, that is x square plus y square plus z square, to be minimum. To be minimum or not? Yes. But you all know that the point x, y, z which I have taken here, this lies on the surface or not? So since the point lies on the surface, can I replace z square is equal to 1 plus xy here? So since the point p of x comma y comma z lies on the surface on phi, so therefore u can be written as, that is d square is equal to x square plus y square plus 1 plus xy. 1 plus xy to be minimum. I hope you understand this point, right? To be minimum here. Yes, my dear students, please look at this. So this is to be minimum. Now look at this carefully. So x square quotient, it's a second degree polynomial or not? Yes, it's a second degree function, and x square quotient, y square quotient, both are positive. That means it is minimum. That means it is minimum here. Yes, minimum at the stationary point. So clearly that u has minimum at the stationary point. Minimum at the stationary point. Yesterday I have done this point. Yesterday I told you this point. When x square quotient, y square quotients are positive, that means the function has minimum at the stationary point here. Stationary point. So therefore, find a stationary point here. Find a stationary point. Right? Given by, yes, P is equal to dou u by dou x. Dou u by dou x is nothing but 2x plus y is equal to 0. Q is equal to dou u by dou y, that is 2y plus x is equal to 0. Right? So 2x plus y is equal to 0 and 2y plus x is equal to 0. So this is what the equation. Dear students, these are linear equations which are homogeneous, and the slope of these two equations are a1 by a2 is not equal to b1 by b2. So slopes are not equal. That means it has unique solution. Means, so this implies here x is equal to 0 and y is equal to 0 here. So by solving this, you are getting x equal to 0, y is equal to 0. So that implies z square is equal to 1 plus 0. So z square is equal to, z is equal to plus or minus 1. So therefore, the stationary points are 0, 0, 1 and q. Another point, you can take 0, 0, plus or minus 1, right? So therefore the distance, the d is minimum at the point 0, 0, plus or minus 1. Therefore d min is equal to here under root of 0 square plus 0 square plus 1 square, that is equal to 1. Shivika Singh is asking, sir, can you tell again why u is equal to d square and not u is equal to d? सुने नहीं क्या बेटा? ठीक है, I will explain it again. What's happened beta? Why are you, so somewhere it is. Now see, when root Shivika, please look at this. Root x is minimum when x is minimum. This is the concept. So instead of making the root x as minimum, we make x as minimum, because if x is minimum, so automatically root x is minimum. Please understand this point. How clearly u has minimum at the stationary point? Dhruv Chatter, please go to the yesterday's recorded session and look into that. And even today's lecture also you can go back and look into that, because I have explained why it is minimum at the stationary point. I have explained here also. वो भी सुने नहीं आप? कल भी पढ़ाया था मैं, ये शॉर्टकट बोल के बताया था भी, और उसके ऊपर 2 प्रॉब्लम भी किए थे. 2 प्रॉब्लम किए थे लिटरली. I have done 2021 problem also I have done, and that 2021 problem also I did it in 2 different methods. कहाँ सुन रहे हैं, कहाँ कर रहे हैं, या सब कॉन्सेप्ट को ऐसा जल्दी कैसे भूल जा रहे हैं? शॉर्टकट को भी भूल जाता है बेटा, ऐसा थोड़ी ना होता है. See, again I'm telling you, please listen. See, when I'm instructing something to you means please follow it, because The same thing you will repeat in the next topic also, na. So then what happens is, repeating the same, never the syllabus will be completed. Because mathematics, only remember one thing. In mathematics, how many different problems you come across and how many number of problems you do, that much clarity and confidence you get in this subject. That is the simple logic in doing the mathematics subject. Okay. So that is why let us not waste the time in repeating the things for same thing for number of times and doing the same thing. If I say very strictly to you that, so how can you forget the shortcut? That means you should understand yourself that okay, I am doing some mistake. So अच्छा मैंने शॉर्टकट पे कैसे भूल गया, क्या पॉइंट बताए ने सर, एक बार पीछे नोट्स पे जाके देखना पड़ेगा. ऐसा थोड़ा कोशिश करते हैं ना, ये कोशिश आपको कभी वो पॉइंट को भूला नहीं देगा. कभी you never forget that point. I'm telling you. Okay? The effort from your side, whatever you put, that is it is take the major picture in your mind. I'm telling you. Okay? एक बड़ी इंप्रेशन लाएगा जब आप क्वेश्चंस करते हैं, राइट? बट जब हम करते हैं तो उसका फील आ जाएगा और उसका कैसे हो रहा है, क्या हो रहा है, एग्जैक्टली पूरा फंक्शन के बारे में कैसे हो रहा है, you will understand everything detailedly. But once you do it on your own, so then it will be perfectly pictured in your mind, so that you never do any mistake or you never forget that concept again. Okay. So okay beta, sir, we can find the minimum value here just by looking at the quadratic equation. Very good Nana, very good. Also the minimum value of x square plus x square and y square is 0. Yes, why not? Why not, my dear? The same function here. Yes, correct. Both are same, na? Smriti, why you have taken stationary point z is equal to +1 in P and Q separately? Because I have got z is equal to plus or minus 1, 2 points, but x is equal to 0, y is equal to 0. When x equal to 0, y is equal to 0, I got z is equal to plus or minus 1. That means two values of z I got. So therefore, two different stationary points I got. So one is of 0, 0, 1, other one is of 0, 0. So one is of 0, 0, 1, other one is of 0, 0, minus 1. Okay. So therefore, if you take this point or this point, take from the origin, the distance is going to be 1 only. Smriti, Shiksha. Sir, square terms have always local minimum. No, 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 no. नो बेटा, नो नो नो, ये क्या है बेटा, क्या क्या पढ़े थे कल शॉर्टकट? दिव्य भारती, ठीक है बेटा, आई विल रिपीट. ओके okay beta, I'll repeat here but I will not repeat again. I'm telling you, because I have to do many shortcuts, many things I have to do. अरे इतना बढ़िया शॉर्टकट आप ऐसे कैसे भूल सकते हैं बेटा इतना जल्दी? That is the shocking for me. That's why I'm taking this much time. I'm unable to digest that. Okay, right, look at this. Here x square quotient and y square quotients are positive. Okay, let me tell you like this. It's a second degree equation or not? Yes. Since it is a second degree equation and x square and y square quotients are positive, then we can straight away say that that function will have the minimum value at the given stationary point. This is the point yesterday I told you. That's why I told you clearly. Afreen Rijvi, sir, I am new here. I only joined yesterday. If possible, then could you please tell me how much you have covered till now? It's I have covered 15 hours, 20 hours plus 10 hours, 30 hours already done. 30 hours, half of the session is done. But still, no issue. You can continue because it's an integral part. You can continue. Yes, but that is somewhere some plus minus and okay. Anyone has still doubts? Please tell me. If anybody has doubts, let me explain this here itself. Agar, see, I'm telling you, if you are asking these very basic doubts, so sometimes I feel that some effective shortcut, just like look at the question and say the answer. So that is, uh, I feel that it is not possible for you. But if I tell that, again, these people will come into that and what is that, sir? What is this? I don't know, I don't know, I don't know. Come on, come on, come on. See, the thing is, the students who are having some little knowledge of the some concepts, so then for them, we can give a little different way of approach, right? So like this, you can see this. This same question I am going to take like this. See, what is the function beta? The function is z square is equal to 1 plus xy. So, I don't know how many of you will understand. I'm not sure. I'm not going to repeat this one. So, this is the simple shortcut I feel. Okay. So, what the shortcut for this? But it does not apply every time. Only for specific functions it is applied. So, see that. So, this is the function z square is equal to 1 plus xy. Right. If you replace x by minus x and y by minus y, so the function will not change. So that means for x less than 0, x greater than 0, y less than 0, y greater than 0. So the function remains stationary. Z square is same value. Z square gives you same value. So that means it is very, very clear that it is symmetric about xy plane. It is symmetric about xy plane. And even if you replace z by minus z also, there is no change. So if you put x by minus x, there is no change. Y by minus x by minus x and y by minus, all these three put together. X by minus x, y by minus y, z by minus z. Equation does not have any change. So that means, so whatever it is positive plane, it will be in the same in the negative plane also, it will be the same here. So therefore, I can say, and moreover, this function is z square is equal to 1 plus xy. So it is a positive side. It's a positive quantity, right or not? So therefore, I can say like this. See, this is a x, y, z, suppose. So this is z, this is x, and this is y here. Now, I said it is symmetric about x, y, z axis. So this is at origin. Even I can say that this is symmetric about origin. This is symmetric about origin. So this is z, na? So this is a positive z, and I say this is negative z, right? So this is a negative z, something you can see the plane like this, right? So you can see the plane like this, right? You can see the plane of three-dimensional plane. You can see that. So it is z, suppose it is minus z, suppose. So for whatever for minus z also same value of the function, and for plus z also it is also same value function. But for plus z, if you take and x is replaced by minus x and y is replaced by minus y, the function is not changing. That means it is symmetric about origin. It is symmetric about origin means, so this will be of this side here. So this is the phi. Okay, the together it is. This is the phi here it is. This is the phi. So now you can see that here. It is symmetric about x, y, z. It is a symmetric about z, x and y and origin. So since it is symmetric about origin, so here I can say this definitely cuts the z axis. It definitely cuts the z axis here, right? It definitely cuts the z axis means here. So definitely this point is something here. Okay, x0, y0, right? And here also x0, y0, because it touched the x axis. Now it is going to be what? So what should be the value here, so that you will be getting this one? So it is going to be, can I say this is a perpendicular distance from these 2 points? All of you? So the perpendicular distance from these 2 points is what here? So now if you put x equal to 0, y is equal to 0 in this, so z is equal to ek hai plus 1 or dusra minus 1. So since it is a perpendicular distance here, see that, since it is a perpendicular distance, so and this is a perpendicular distance, this is the perpendicular distance at this point. So therefore, always we know that the perpendicular distance will be the shortest distance. So therefore, the shortest distance will be 1. This is graphically better. Okay. So I don't know that you people will understand this because you don't know the concept of curve tracing. You don't know how to draw the curves. You don't know how to draw the surfaces. So that is why, so you may not understand this concept here. Okay. Here what I am trying to say that if you replace x by minus x and y by minus y and z by minus z, the function is not changing. So that means it is symmetric about origin. So origin ke ek taraf, origin ke dusri taraf, the function remained same here. So this surface whatever is here and that side also the same surface you will have. That's what the thing you can say that, right? Okay. But it is having in negative plane and it is also having in positive plane, right? Okay. Now you can see if I put at x equal to 0, y is equal to 0, z is equal to plus or minus 1. So that means this surface is touching the z axis at 0, 0, 1 and 0, 0, minus 1. So this is a rough sketch, right? So at x equal to 0, y is equal to 0 on z axis. So z axis z square is equal to 1 means z is equal to plus or minus 1. That means it is very clear this surface is cutting the z axis at 0, 0, 1 and 0, 0, minus 1. So therefore after drawing this and like this, so now you can see, so at this point this will be this perpendicular distance from the origin. So this is the perpendicular distance from the origin to this point and this is the perpendicular distance origin to this point. So therefore the distance will be minimum distance, that is 1. Okay. I don't know how many of you understand this. Yes, Manvish, even I too feel the same. A lot of time is getting wasted. If proper revision is done, one will not forget the shortcuts. Yes, this is what I wanted to stress it. But you know, the majority of the students, if they do not understand, you know, they feel so low. So that I don't wanted to see. That is the major problem. But if I ignore you, if I start ignore you, there will be, you know, kind of thing here. So that's why I am spacing time, but it causes some disturbance from others, for others also. I understand this. Okay, I think we have to move on it, right? Is the curve is a part of GATE syllabus? My God, it is not in the GATE syllabus. Pradum, you have got it, Meta. Very good. Thank you, Meta. Thank you so much. Salim, you also understood. Thank you. Akshay, understood. Thank you, Beta. Thank you. Very good. Even function concept for graph also. Very good, Chinmay. Anyway, Beta. Thank you. Thank you. Thank you. Chalo, 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 chalo. Okay. Right, 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 right. I think we are taking a lot of time, my dear. That was the major issue. The first point, we'll take the shortcuts. Okay. The first one is, right, for all x comma y, for all x comma y belongs to R. Okay. If x plus y is equal to k given, then A xy, the product of this xy is maximum at x is equal to y is equal to k by 2. Okay. Second point, x square plus y square is minimum at the stationary point x is equal to y is equal to k by 2. And the third one, that is x cube plus y cube, is minimum at x is equal to y is equal to k by 2. So these are the points under the same condition. Under the same condition, so these three things you can do it. You can have the second one. Okay. Second one, maximum area of rectangle inside an ellipse, x square by a square plus y square by b square is equal to 1 is 2ab. 2ab. So third one is that the maximum area of this rectangle here, the maximum area of rectangle inside a circle, x square plus y square is equal to a square. Maximum area of a rectangle inside a circle of radius, like this way I will write it, circle of radius r is 2r square. 2r square. R square. And the fourth one, maximum height of the cone, inscribed in a cone having largest volume inside maximum height of cone having largest volume inside a sphere of radius a units is equal to 4 by 3 h is equal to 4a by 3. 4a by 3. Right. And fifth one, the maximum height of the cylinder having the largest volume inside a sphere inside a sphere of radius a, inside a sphere of radius r, is that 2r by root 3 equal to 2r by root 3. Aniket Mish. Thank you, Seema. Thank you, Disha. Good, Chandu. Okay, if the curve is asymmetric, then we have to use the normal procedure. Yes, Padma Priya, you are correct. I told you. That's what. For some part only. Yes, correct, correct. You are right. No, only xy is a rectangular hyperbola. Only xy. Good or no? Very good, Nana. Very good. So these are the shortcuts here. So let us use these cases. Okay, let us use these cases. Okay, if you want a small simple explanation here, sir, how these all comes and all those things means. So let me explain you that point here, all of you. See, this is the constraint. This is the condition, right? So what I told you, use the condition into the function. So from this one, I can write y is equal to k minus x. Okay, okay, that you substitute in xy. So then xy becomes what? Then xy becomes, if you put it in this, then this is x into k minus x, right? So this is nothing but, okay, so the stationary points are given by here k minus it is kx na. So the differentiation of this one is k minus 2x. So x is equal to k by 2. Stationary point will give you x is equal to k by 2. So that implies y is equal to k by 2. See that? You can see. And its a second derivative will be, it is k minus 2x means minus 2. Minus 2 is less than 0. Means it is maximum at this point, stationary point. That's a simple funda here what I have done. What I have done is that I use this condition into the function which you are maximizing, that is xy. So xy को maximum कर रहे हैं. So let us write the y is equal to k minus x into this xy, and I am getting the function x into k minus x as the new function. So we need to maximize this. But you know the maximum exists at the minimum stationary point. So therefore stationary points are given by f dash of x is equal to 0, so that you get x equal to k by 2. So if x equal to k by 2, as per the condition, y is also k by 2. So therefore here, so and second derivative if you find, you are getting negative. So second derivative is negative means what? The function is maximum at the stationary point. So maximum at k by 2 comma k by 2. So that is what here. xy is maximum at x is equal to y is equal to k by 2. Similarly, you can prove this one, you can prove this one, you can do this one, and you can do this one, you can do this one, and you can do this one. Only thing is use the constraint into the function and make it maximize. Okay, right. Okay, my dear students, let's start the questions on this. Let's start the questions on this year. Now there is a 2020 question which is asked for 1 mark. Now find the minimum value x square plus y square with respect to the straight line, x plus y is equal to 1. So this is the 2020 question. I told you yesterday when I was leaving that from these shortcuts we were getting the questions from 2019 onwards. So when I have taken all these type of shortcuts from 2018 onwards, so I took them in the class, and from 2019 onwards we are getting every year we are getting the question on these shortcuts. So we have seen this. What is the answer here? Shortcut 1 applicable in aptitude problem also. Why not? Yes. Right, here it is. So by shortcut, which one? By shortcut number 1 point B, I think 1 point B. So 1 dot B. So shortcut number 1 dot B is by shortcut number 1 dot B is that x square plus y square is minimum, okay, is minimum at x is equal to y is equal to k by 2. So what is k as per this question, my dear? So the k is equal to 1. So k is equal to 1. So that k, if you put it in this, then you are getting it as 1 by 2. So x square plus y square is minimum at x is equal to y is equal to 1 by 2. So therefore here the minimum value of x square plus y square, okay, is nothing but 1 by 2 whole square plus 1 by 2 whole square. So that is nothing but 1 by 2. Yes, beta, ये question है. Next I am going to another question. Yes, let's go to the next question. Find the maximum. Okay, let me take this question. Okay, let me take this question. A is a 2 by 2 real symmetric matrix. A 2 by 2 real symmetric matrix having real symmetric matrix having the trace is equal to 14. Trace is equal to 14. Then find the maximum value of its determinant. Right. So this question is a very good question. So this is also gate examination, but this is given for 2 marks. So A 2 by 2 is a real symmetric matrix, dear. So I can say A 2 by 2 is real symmetric here. So it is symmetric means, can I say that lambda 1 comma lambda 2 are real and positive or not? Sorry, real. I'm sorry. Real. So it is very clear that the lambda 1 and lambda 2 are real numbers. That's what is the point he said that the symmetric matrix is. So why he has mentioned symmetric matrix especially? Why can't he say that some other matrix? Because for some other matrix, if you take the eigenvalues, that is lambda 1, lambda 2, may be complex, imaginary. But for the symmetric matrix, definitely the eigenvalues will be real numbers. So that's what the case here. So, and given the trace of A2 by 2 is equal to lambda 1 plus lambda 2, that is equal to, here it is how much? It is 14. Lambda 1 is equal to lambda 1 plus lambda 2 is equal to 14 here. So this 14 is equal to k. I am saying that suppose if this lambda 1 plus lambda 2 is equal to k, where this lambda 1, lambda 2 are real. This lambda 1 and lambda 2 are real, and sum of these two is nothing but k, which is 14 here. Now he is asking the maximum value of its determinant. So we know that here the determinant of A2 by 2, that is mod A2 by 2, determinant of A2 by 2, okay, is nothing but the product of lambda 1 and lambda 2 here. So this is maximum. Now the determinant of A2 by 2 is equal to lambda 1 into lambda 2 is maximum here. Hope you understand. Is maximum, okay, when lambda 1 plus lambda 2, when lambda 1 is equal to lambda 2 is equal to k by 2, that is 14 by 2, that is 7 here, by shortcut number 1.a, by shortcut number 1.a here, okay. Hence mod A max is equal to lambda 1 into lambda 2 max is equal to here 7 into 7, that is 49. 7 into 7 is equal to 49. So this is the answer, my dear. See, it's a linear algebra question and as well as maxima minima question. So it's combinedly it is asked. Now we'll do one question here. Question number, yes, we'll do the question number, that is of 37 and 31. What is the answer for 37 and 31? So first 37 will do it. 37 question. X square plus 9y square is equal to, 4y square is equal to 1 is given, right? So 37 question, if you see here, the maximum area of a rectangle whose vertices lies inside the ellipse. So the ellipse is this. The ellipse is this. Okay. Now the ellipse is this. So this is origin here, right? And now oh, wait a minute. Right. So this is the ellipse here, and now you have to take any suppose this is the rectangle, you take it here, and there are so many rectangles you can take within this ellipse. Within this ellipse, so many rectangles you can take. But out of these all rectangles here, what will be the maximum area of rectangle? Okay, what will be the maximum area of rectangle we will have? So that is given by this shortcut number 2 here. So by shortcut number 2, here, so the delta maximum area of rectangle inside an ellipse is equal to 2AB. But what is 2AB? Let's write. What is A and what is B? Let's write this equation into standard form. See, dear students, writing this equation into standard form of ellipse, that is x square by 1 square plus y square by, here this 4 will come down, so that is 1 by 2 whole square is equal to 1. So now I can say that A is equal to 1, so B is equal to 1 by 2. A is equal to 1, B is equal to 1 by 2 here. So here this answer is going to be 2 into 1 into 1 by 2. 2 into 1 into 1 by 2. So 2 gets cancelled and the answer is 1 here. So this is the way the shortcuts are helpful, and this is also GATE examination question for 1 mark. ये भी गेट वाला है. This is also GATE examination question. Yesterday, e to the power of sin x by e to the power of cos x problem also we have done, whether you remember it or not. Okay, so that is also some interesting shortcut here. So that was also GATE examination question. Remember this. (37) is also done. Now we will go for 31 question. So what is the answer for 31 question, dear? It's not 1 by 2. It's 1. It's 1, my dear. Divya Bharati, you have done wrong. Because you have not written the ellipse equation into standard form, that is x square by a square plus y square by b square is equal to 1. So taking that 4 with y square into the denominator as 1 by 2 whole square. So b will become 1 by 2 and a will become 1. See this. Writing this equation into standard form and then you take the a and b value. So without using shortcut, how can we solve this, sir? Yes, Arnav Goyal. So what you do is that here, now, in this case, what you can take is x is equal to, okay, this is x units, then this is also x units because this is origin, right? This is y unit, this is y units. So therefore, I can say the delta, that the delta is the area of this rectangle is going to be 2x into 2y, that is 4xy. That is 4xy here. Okay, this is the function to be maximum. This is the area to be maximum with respect to this ellipse. My dear students, here what I do is I'll take x is equal to, yeah, from this I can take, I think you know the parametric forms of ellipse equation. So that is x is equal to a cos theta, y is equal to b sin theta here. B sin theta. So if you put this into this one, if you put this, because the ellipse is the condition. Ellipse is the condition here. And the function is the area of rectangle. So area of rectangle we need to maximize with respect to x equal to cos theta and y is equal to half sin theta. So therefore this is goes to be 2 sin theta cos theta here. So which goes to be sin 2 theta, right? So therefore here we can say the delta max is equal to what? The delta max is equal to the maximum value of sin theta. So what is the maximum value of sin function? 1. So the answer is 1. So you are getting 1. Arnav Goyal, I hope you understand. So you can go with this method also if you want. So using the constraint into the function and then we need to maximize it. Okay. So 31 question, my dear. 31 question. So 31 question, direct answer is h max is equal to 4a by 3 by shortcut number 4, I think. By shortcut number 4, I think. So this is going to be 4 into 1 by 3. So that is 4 by 3 is the answer. 4 by 3 is the answer for this question. Okay. Very good. 4 by 3 is the right answer. Excellent, beta. Very good. Now, let's take another question. Find the maximum height of, before this, I'll go for this. Find the area of shaded region in the graph. In the graph. Here, the graph is this. Note that the rectangle inside the circle has the maximum area. This is the question. Okay, this is the condition. That is, find the area of the shaded region. So this shaded region I want to find. Okay, note that the rectangle inside the circle having maximum area. So this is one question, my dear. So this one is also GATE examination question. 2021. Sorry, 21 for EC students. For electronics, this question has been come, and even I am telling you, this question has come in aptitude area, not in mathematics. In aptitude, this question has come, but these points we are studying in mathematics here, and that too with the help of shortcuts, we can give the answer for this question without using your pen on the paper. Very good, my dear. So the solution is the area of the shaded one is given by area of the circle minus the area of rectangle. Right? And what is the area of the circle, beta? Pi r square minus and area of the circle. We already know that here this rectangle inside the circle has a maximum area. So then this maximum area is going to be 2r square. That is equal to 2 into 2 square. I hope you understand. So this area of rectangle is going to be 2 into 2 square. So that goes to be 2 square common, that is 4 into pi minus 2, that is 1.14 into 4, that is 4.56. So the answer will be 4.56. This is the answer for this question. Easy question or not? Okay? But if you know this shortcut, you can give the answer very fast. चलो बेटा, एप्टीट्यूड क्वेश्चन भी मैं ही कर रहा हूं. Oh, sorry, sir. I gave answer for the area of rectangle. Okay, beta. Okay. It's okay. No issue. जल्दी में होता है कभी कभी. Nothing to worry. Yes, 2r square. Ashmit Kaur, you're right. Answer is 2r square. Huh? I didn't understood 2r square. Acha, you are saying for this, na? Okay. Okay, beta. I hope you understood this question. So I'll move on to the next question. I'll move on to the next question, dear. This is the last and final question of maxima minima because it's already 3. So yesterday almost we have taken about 4 hours and today 2 hours, 6 hours of maxima minima. I don't understand. I never took the mathematics maxima minima for 6 hours. I'm sorry. This is true because of lot of doubts and all those things. But anyway, uh, you have to focus when something you are learning very first time or something differently you are learning. That's why I always says that my class will be a different approach than any others. So definitely if you concentrate the things you will understand here. Anyway, so please take down this. Next question is that, oh my god, too many questions. Chalo, find the maximum height of cylinder having largest volume. Having largest volume here. Having largest volume. Having largest volume inside an ellipse. Sorry, sphere. Inside a sphere of radius 2 units. So this is the question. Give me the answer very fast. It can be expected in the examination. I'm telling you, it can be expected in the examination because the question has not come on this one. So you may get it. Sentence in bracket is question. Yes, it is in questions, Harsha. That's why I said note that. Okay, it is in the question itself. No, I didn't say Arnav Goyal. I have never seen this batch like this. Okay, right? I said that I never took the maximum minima for 6 hours. Sir, use. Yes. దీనికి yes, Amulya. I think this is enough for maxima minima. We did many questions. We should proceed further after this question. Yes, beta. Give me the answer for this. Thank you, Amit Singh. Thank you. So this one is 2r square by root 3. So that is 2 into 2 square by root 3. Sorry, 2r by root 3. I'm sorry. 2r by root 3. 2r by root 3. So 4 by root 3, you calculate something, you will get it. Okay? Good. Very good. By which shortcut? By shortcut number? Arnav, that was the statement before the maxima minima. Okay? Right. Because we were doing so basics and all. Okay, now we entered into the actual concepts of engineering mathematics. Okay, let's do one thing. So we will go to break. Now we'll take the break. So because anyway, this one is done now. So I'm going to take after the break, I'm going to take the integration concept. Okay, let's take the break. The break is up to 3:15. So now it is break. Okay. So resumes at 3:15 p.m. Okay, right. Chalo, take the break. God bless you, Arnav Goyal. God bless you, beta. God bless you. I can't say more than this. Chalo. Good, good. Very good. Very good. Excellent. Sir, can I have lunch in the break? You can go for lunch or brunch or whatever you want to have. You can have. Okay? Break is for 20 minutes. Chalo.